Good night, and as we turn to the electrotator here, we are, or rather I am, focusing on the first 25 elements of the periodic table, and we have reached up to the 13th, which is aluminum. When we turn to our little notebook here, towards aluminum, all right, and we select aluminum from our little deck here, our package. And so here we have aluminum. We see here aluminum 13, 27.13 atomic atomic number 13 and atomic mass of 27.13. Now, aluminum have one stable isotope, which is the aluminum 27, but it also have another one which is not normally or readily available, which is aluminum 26. And aluminum 26 is radioactive, taking about 1 million years to completely decay. All right, so that's aluminum. We go to our notebook here, and we say aluminum electronics configuration neon 3s2, 3s1. 3s2, 3s1 electronic configuration, and we go to some reactions and properties, physical and chemical properties of aluminum. And we note that it's very reactive, and one stable isotope would be the aluminum, as we mentioned, 27, and aluminum 26 would be radioactive. It's not readily available. It reacts with air to form aluminum oxide. It reacts with sulfur to form aluminum sulfide. It reacts with carbon to form aluminum carbide. And it reacts with chlorine to form aluminum chloride. It also will react with fluorine, aluminum fluoride. So aluminum fluoride, aluminum chloride, and aluminum bromide. It's a good conductor of electricity, but it's not a very good conductor of heat. It's really a good conductor of electricity, but on the other hand, it's not a good conductor of heat. The colder it gets, the stronger aluminum becomes. Now, aluminum reacts with acids. It reacts with hydrochloric acid to form aluminum chloride and hydrogen. I guess with nitric acid, it would react with to form aluminum nitride plus nitrogen. And it reacts with alkalis or alcohol to form aluminum hydroxide plus hydrogen gas. As we said, it's non-toxic. It has a high thermal conductivity, high corrosion resistance, and it's non-magnetic. One of the disadvantages of aluminum, or sometimes the disadvantages can be advantages, but in this case, disadvantages is that the element gallium with atomic number, I believe about 31, we'll come to that when we look at our periodic table, easily destroy aluminum. So any alloy or substance that have aluminum will be destroyed by gallium. A small amount of gallium will destroy everything. That contains aluminum. All right. As we have good electrical conductor, poor colors of heat, and radioactive. Let's see if we have any more properties or further thing with aluminum here in the back. We have the reaction aluminum plus hydrogen aluminum hydride exothermic reaction. 2 aluminum plus 6 hydrogen give you 2L 2LH3S. Chlorine and bromine liquid reacts with aluminum to form at room temperature. Now aluminum reacts with nitrogen to form aluminum nitride, aluminum with carbon aluminum carbide, and sulfur aluminum sulfide. Okay, we'll look at those reactions according to your chemical reactions and chemical symbols and thing later on. But for now, this is aluminum. This is a card. And let's just briefly take a look at the periodic table. Aluminum 13, aluminum. So here we have aluminum in the third period. That would be the M shell. Aluminum Al1327. That is the most available one, isotope. And Al26, instead of 27, would be the radioactive aluminum. So it's in period 13 here. I mean, group 13. And we have it in green here with the group boron and gallium. You say gallium easily destroy aluminum. Anything material containing aluminum that the metal gallium will destroy. 31 and atomic mass of 69.92. And in the same group would be indium and thallium and that one on, which is not readily available but can be synthesized, but it's unstable. But it's in the same group with boron, and we are focusing on aluminum. There's aluminum. Look at some of our notes here. Aluminum with its electronic configuration. 3s2, neon 3s2, 3p1. And that's our little deck with aluminum.